Hi friends, welcome back. In the previous session we had seen about the multi-level queue scheduling where we had multiple queues, each queue having a separate priority and processes whenever they come. The importance of that process is somehow identified and made to sit in a particular queue, and the scheduling is done as per the priority. And another difference was the different queues may work on different types of scheduling. So something may be round robin, some may be on the first come first serve basis and all that. But we had a problem there, that is identifying the correct queue to which any process belongs to. And if something goes wrong in identifying, and it is going to definitely create a big problem in the system, so we need some way out of this. So example, at a time of deciding which queue a given process should belong to, and by mistake an unimportant task is given a high priority and an important task is given a low priority by mistake, then a not very important task goes into the high priority queue and the important task may go into the low priority queue, and so on. And while the scheduling is done, then the first preferences are given with the processes that are in the high priority queue, and hence all the processes in the high priority queue get the chance before the processes in the low priority queue. But by mistake, some process that is not very important is in the high priority queue and it gets chance to run first. But may happen that a process with a high priority having more importance was wrongly classified as a low priority process and hence put in the low priority queue. And what could happen is that the low priority process, which was supposed to be in the low priority queue, has gone into high priority queue, so it gets a chance to run earlier. And if it is going to take too much of time, then what could happen is the really important task, which was misclassified as a low priority task, keeps waiting till this unimportant task is being executed, which is taking quite long time. So we need some way out. So it is very difficult to decide at the time of classifying which queue a given task should belong to, but we should have some means to modify the position of the process. So we should be able to change the queue from one queue to another queue and so on. So like if an important task by mistake went into high priority queue, then we should understand that there is something wrong. It is taking unexpectedly long time to complete, and we should somehow make it go down onto a lower priority queues. So we should be able to shift them to the lower priority queues. And other side, low priority queue tasks, if they are not able to get attention of the CPU for a very long time, then there should be some way out. Instead of keeping that process star, we should somehow make it visible to the CPU, and this we can do by shifting this process from a low priority queue to high priority queue. So we can upgrade the priority queues for long pending cases, and we can downgrade the priority queues for the processes which are unnecessarily wasting the CPU time and all that. And that is what is the main idea behind multi-level feedback queue scheduling. So the feedback is the one which is the important thing here, and what feedback means here is to learn with time. So just keep changing the priorities as per the requirement. So the system here watches the process and adjusts the priority of that process accordingly. So promoting it if it is waiting for too long, or demoting it if it is wasting CPU's time and all that. So that's what we have with a multi-level feedback queue scheduling. So this uses multiple queues, and each queue can be different, can have different priority, and can have different scheduling strategies. And most important thing is here, this can allow process to move between the queues based on their behavior. Like if the process in a high priority queue is wasting CPU's time, then its priority can be reduced. Or if a low priority process is waiting for a very long time, then instead of keeping it star, we can just upgrade it and move to the higher priority queue. So here that is possible, and this movement is based on the behavior, and behavior we get from the feedback. Here the feedback means the system learns about the process behavior while it runs, and this will help the operating system treat the interactive and batch processes totally differently. So how does this scheduling algorithm works? So whenever we are talking about the multi-level feedback queue scheduling, then we do have multiple ready queues, and each queue has a different priority level. So if we say Q0, Q1, Q2 and so on are the queues, then Q0 will have highest priority. That's as per our convention. So whenever a new process comes in, and whenever a new process begins its journey, it has to go into a ready queue. But there are many ready queues, so it gets into the ready queue which has got the highest priority. And if this process is running very slow, so for every process a time quantum is decided, and within that time quantum we expect that to complete its task. So the time quantum varies from the queue to queue. So from the highest priority queue, the time quantum may be small, and the lowest priority queue, the time quantum may be large. And depending on that, so if it is at the beginning, it gets into the first topmost priority queue whose time quantum is smaller, and we expect that the top priority jobs should complete their task as soon as possible, and that's what the priority is all about. So we want slowly moving things to be given low priority, we want the fast moving things to give high priority, so that the throughput, CPU utilization and all are good. But if the time quantum is complete, then we understand that this process is not suitable for this particular queue, so it is moved to the next lower priority queue, and that way it continues. On the other side, from the bottom side, if you look at it, if you find a process which is waiting too long, so since very long time it is not getting a chance to get the CPU's attention. That means it is under starvation. So to prevent starvation, it will be promoted to the higher priority queue. So this is happening through the feedback. Just observe what is happening. Anything which is on the top priority queue and not able to utilize the things as per the requirement, then it will be demoted, and any process which is unnecessarily waiting for its turn to come, then it will be promoted to the higher level, so that starvation can be reduced. And the other side, any process is wasting time of the CPU resources and all, then its priority is reduced, demoted, so that the overall efficiency, overall utility, overall throughput is maintained high. And here the each queue can use different scheduling algorithms, like some queue may use round robin at the top and first come first serve at the bottom queues. So looking at the advantages and disadvantages of this type of scheduling algorithm, it's very good for responsive interactive processes. So interactive processes will get a high priority, so they get into the higher queue and will respond immediately. And it is also efficient for long running batch jobs, because they are put on the lower end. And adaptive, main important thing is there is where the things can be modified with time, so nothing static, it is dynamic in nature. So the priority of any process can be dynamically modified depending on the behavior of the process. And it is fair enough, because it prevents the starvation with the aging or promotion. That means aging means going it down, promotion means making it up. Yeah, nothing comes freely, so it is too complex to implement and tune. Yeah, that is a big problem. So now the question comes here is what are the parameters to consider for upgrading or degrading any process from one priority queue to the another priority queue. So a proper conditions have to be put forth, so it will too complicated, and it requires careful setting of how many queues are required. That's the first place. So the number of queues depends on the situation. If the number of queues is too large, we have one problem. If the number of queues are too small, then we miss the advantage of multi-level queue scheduling. And if they are too large, then deciding which queue to come first, which queue to done, again will be a difficult thing. Then deciding the time quantum for each queue is another challenge in this type of scheduling. And rules to promote the queue from the process from one queue to the upper queue, or age, that is demoting from the high priority queue to the low priority queue. So what are the conditions they should fulfill, any process should fulfill to declare itself that it is being starved, so that it will be elevated to the next priority queue? Or who is going to decide, and how any process is going to be decided that it is not fit to live in the high priority queue, it should be downgraded down to the low priority queue and all that. So finding these rules and all are quite difficult. So if you find this interesting, so please do like, comment, share, and please subscribe to this channel. Thank you.